The desert of southern Iraq is quiet at night. When the heat finally releases its grip, the land exhales and the sky opens wider than it does almost anywhere else on Earth. Thousands of stars emerge, sharp and unblinking, stretching from horizon to horizon. Even now, it is easy to understand why the first cities were built here, not because the land was gentle, but because the sky was impossible to ignore. 5,000 years ago, people stood on this same ground and watched those same stars rise. But they did not look up with wonder alone. Something in their writing suggests a different emotion entirely. Not awe, not reverence, but vigilance. We are taught that the Sumerians were the first civilization to record the heavens out of curiosity, spirituality, or a desire to impose order on chaos. That they named the stars because humans always name what they fear losing. Yet when their earliest tablets are read closely, another possibility emerges. The sky was not an abstraction, it was not distant, it was not benign. It was something that had already proven itself capable of destruction. What if the Sumerians did not study the sky to understand it, but to survive it? The oldest cuneiform tablets recovered from sites like Uruk, Eridu, and Sippar do not read like the hesitant notes of a culture just learning to observe nature. They are precise, confident, unapologetically technical. They record cycles, crossings, and returns with an assumption that the reader already understands why these things matter. There is no explanation for why the sky should be watched so carefully, no justification for why certain stars are dangerous. The texts do not persuade, they remind. That absence is unsettling. Before we go any deeper, feel free to let me know in the comments where you're listening from tonight and what time it is there. I always enjoy reading those messages. There's something quietly fascinating about seeing how these ancient questions ripple across the world from one place to another in the dark. And just as a small note, the images you're seeing are simply there to add atmosphere and context. They aren't meant as literal reconstructions. Thank you, as always, for being here and for supporting this journey. A civilization does not reorganize its calendar, its priesthood, and its architecture around superstition alone. It does so around risk. The Sumerians tracked the heavens with a level of seriousness normally reserved for threats that have already revealed themselves. Their sky was not a source of inspiration. It was a system to be monitored. In later cultures, astronomy grows slowly. Early star lore is vague. Constellations drift. Calendars are corrected again and again, but in Sumer, the record opens already refined. Venus cycles accurate to the day, lunar intervals mapped with consistency, planetary movements described with an understanding of retrograde motion that would not reappear elsewhere for centuries. There is no visible childhood to this knowledge, no phase of trial and error preserved in clay. It is as if the curtain rises on a civilization already alert. That alertness seeps into the language itself. Many Sumerian astronomical texts use terminology that modern translators long rendered as religious metaphor. Words for evil wind, burning breath, and stones of heaven were placed comfortably within the category of myth. But myth in these texts sits side by side with irrigation schedules, legal codes, and mathematical tables. The same scribes who calculated grain yields also recorded celestial dangers. The same tablets that documented temple inventories warned of seasons when travel should cease and cities should prepare. The blending of the mundane and the cosmic reveals something crucial. The sky was not separate from daily life. It was integrated into decision-making, into governance, into survival. This integration only makes sense if sky events had tangible consequences within living memory. The Sumerians described certain stars as crossing, scattering, or bringing heat. They noted times when the horizon burned though no fire was lit, when winds came without clouds, when darkness lingered after sunrise. These phrases appear again and again, not as isolated poetic flourishes, but as recurring markers tied to dates and cycles. The implication is subtle but profound. The danger was not random. It followed patterns. And patterns imply recurrence. Long before later cultures would mythologize the heavens into distant realms of gods and destiny, the Sumerians treated the sky as something immediate and actionable. They assigned watchers. They established protocols. They built elevated platforms not merely to honor deities, but to see farther, earlier, more clearly. Their temples rose not only toward the heavens, but towards specific regions of the sky, as if something there demanded constant attention. If this vigilance feels excessive, it is because we have forgotten what it feels like to live beneath a threatening sky. Modern humanity experiences celestial danger as abstraction. Asteroids are headlines. Meteors are spectacles. Planetary defense is a budget line item discussed in committee rooms far from the night air. But for the Sumerians, the sky was not hypothetical. It was part of the environment, no different from rivers that flooded or winds that stripped fields bare. Except rivers announce themselves. The sky does not. To watch the heavens is to accept that destruction can arrive without warning, from a direction no wall can block. If the Sumerians embedded fear into their cosmology, it was a rational fear, shaped by observation and loss. Their gods did not merely rule the sky, they emerged from it. They carried fire, they scattered fragments, they brought seasons of dust and silence. These were not moral stories, they were environmental ones. Across the ancient world, myths of fire from above and darkness without storm appear with uncanny consistency. But Sumer stands apart in one critical way. They did not stop at telling the story. They measured it. They tracked it. They turned memory into mathematics. This suggests a civilization haunted not by a single catastrophe, but by the knowledge that catastrophe could return. What does it mean for a culture to believe that the sky itself follows cycles of danger? It means every generation inherits not just land and language, but responsibility. Someone must keep watch. Someone must maintain the count. Someone must remember what happens when vigilance lapses. And memory, as the Sumerians seem to understand, is fragile. Clay cracks. Cities fall. Languages vanish. Yet their texts are written with an urgency that assumes failure is inevitable, that someday the meaning will be lost, that someday the warnings will sit unread. Perhaps that is why the language is so repetitive, why the same dangers are named again and again across centuries. Not because the scribes lacked imagination, but because they feared forgetting more than boredom. Sometimes the most important part of a message is not what it says, but what it assumes. The Sumerian tablets assume the sky can kill. They assume it has done so before, and they assume it will do so again. Standing beneath the same stars tonight, it is tempting to dismiss this as ancient anxiety projected onto an indifferent cosmos. But the Sumerians did not project fear outward. They encoded it inward, into systems designed to last longer than rulers and dynasties, into calendars that reset annually, into rituals that forced attention at precise moments, into stories that could survive even when the technical language failed. They built a civilization around watching. As you listen, perhaps from a darkened room, perhaps with sleep already pulling at the edges of awareness, consider where you are hearing this from, what time it is where you are. The Sumerians would have noted that too, not out of ritual, but out of context, because time and place matter when the sky changes. They believed danger returned on schedule, and if that belief shaped the birth of civilization itself, then understanding why they were so certain becomes more than an academic exercise. It becomes a question of inheritance, not of knowledge alone, but of fear carefully preserved. The next step is to ask how such certainty could exist at all, how a people standing at the dawn of history could already possess knowledge that feels like the end of a long story rather than the beginning. To answer that, we must look not at what the Sumerians built, but at what is missing beneath their foundations. Beneath the ruins of Eridu, archaeologists expected to find beginnings, rough tools, crude experiments, the tentative marks of a society learning, slowly, how to organize itself. Instead, they found refinement layered atop refinement, temple foundations aligned with precision, mathematical notation already standardized, astronomical references embedded so deeply into the earlier structures that there was no earlier, simpler phase to peel back toward. It was as if the first pages of the story had already been torn out. In most civilizations, knowledge leaves fingerprints of its own development. Early calendars drift, star names change, measurements contradict one another. Corrections accumulate over centuries as errors are noticed and repaired. This is how learning normally looks in the archaeological record. Hesitant, uneven, human. But the Sumerian record opens differently. From the moment writing appears, it appears mature. Cuneiform does not begin as a loose system of marks that gradually crystallizes into meaning. It arrives already capable of encoding law, commerce, medicine, poetry, and astronomy. Even more unsettling is that its astronomical vocabulary is already specialized. The earliest tablets distinguish between planets and fixed stars. They recognize irregular motion. They categorize celestial events by consequence, not appearance. This is not the language of beginners. The Mu'apin star catalogue is often cited as evidence of Sumerian astronomical brilliance, but what matters most is not its sophistication. It is its confidence. The catalogue does not explain how the stars were identified. It does not justify why certain cycles matter. It simply states them as facts long agreed upon. Rising times are listed with seasonal regularity. Constellations are fixed. Planetary paths are tracked with consistency that modern simulations have verified as accurate for the period. Accuracy alone is impressive, but accuracy without explanation is revealing. A culture discovering astronomy would celebrate discovery. It would mythologize uncertainty. It would preserve debates and contradictions. The Sumerians preserve none of that. Their texts read like maintenance manuals, like updates to an existing system, as if the work was not to discover the sky, but to keep its record intact. This absence of a learning curve extends beyond astronomy. Sumerian mathematics appears already optimized for cyclical calculation. Base 60 is not intuitive. It is cumbersome for daily counting, but extraordinarily powerful for tracking fractions, angles, and repeating intervals. It is ideal for astronomy, ideal for calendars, ideal for long-term cycles that need to be subdivided precisely. Why would the first civilization choose such a system unless cycles mattered more than convenience? At sites like Uruk and Nippur, early administrative tablets sit alongside astronomical ones, sharing notation, structure, and scribal style. This suggests the same institutional framework handled both earthly and celestial matters. Grain inventories and star movements were not separate domains. They were part of the same accounting logic. The implication is subtle but profound. The sky was not a subject of curiosity, added later to an already functioning society. It was foundational, built into the administrative spine from the beginning. Even architecture reflects this priority. The earliest temple layers at Eridu, dated to well before 5000 BC, already show orientation choices that make no sense for climate, defense, or trade. They align instead with horizon points tied to specific stellar risings, and these alignments persist through multiple rebuilds, adjusted slightly over centuries to compensate for precession. This means someone was watching long enough to notice the sky slowly shifting. Precession is not something a single lifetime can detect. It reveals itself only when observations are compared across generations. To track it, records must survive loss, upheaval, and collapse, or be inherited. The Sumerian kings list hints at this inheritance obliquely. It speaks of rulers before the flood whose reigns lasted impossibly long spans of time. Modern readers dismiss this as myth, but within the logic of the texts, these long reigns serve a purpose. They compress memory. They bridge eras. They preserve continuity across catastrophic breaks. In this way, time itself becomes a tool. If the Sumerians saw themselves not as founders, but as inheritors, their sudden sophistication makes more sense. They were not starting from nothing. They were reconstructing, recovering fragments of a system that had existed before memory fractured. This interpretation reframes the famous question of Sumer's origins. Instead of asking how civilization began so suddenly, we ask what civilization was rebuilding from. What knowledge survived long enough to be encoded into clay? What priorities were considered too dangerous to forget? The star catalogues do not read like discoveries. They read like restorations. And restoration implies loss. In later texts, Sumerian scribes occasionally use phrases that translators render as "from before" or "according to the old count." These phrases appear without explanation, as if their meaning were obvious to the intended reader. They reference standards that predate the tablets themselves, measures older than the cities in which they were written. One inscription from Sippar describes a temple as the restoration of what was before, not the creation of something new, but the rebuilding of something damaged or destroyed. This language appears again and again in early dedications, quietly contradicting the narrative of first invention. The deeper archaeologists dig, the more elusive the beginning becomes. There is refinement everywhere, but no origin point where refinement gives way to experimentation. One French archaeologist working at Lagash famously remarked that the excavation felt like digging through the aftermath of something rather than its birth. If that is true, then the Sumerians' obsession with cycles takes on new meaning. Cycles are not comforting to those who have only known growth. They are terrifying to those who have known collapse. A society that believes destruction returns does not celebrate linear progress. It measures time differently. It counts. It watches. It prepares. And it teaches its children not just how to build, but how to remember. Memory in this context is not nostalgia. It is infrastructure. The Sumerians built that infrastructure into writing, mathematics, architecture, and ritual. They created systems that could survive kings, droughts, invasions, and even the forgetting of their original purpose. Because the danger they were tracking did not care whether anyone remembered it. It would return regardless. This raises a more uncomfortable possibility. If the Sumerians inherited astronomical knowledge already refined, then someone before them had reason to refine it. Someone experienced the sky not as pattern, but as threat. Someone watched long enough to recognize recurrence. And someone ensured that recognition did not vanish when their world did. The Sumerians may not have known the full story of that earlier catastrophe, but they knew enough to take it seriously, enough to build their civilization around vigilance rather than optimism. To understand what taught them that lesson, we must turn to the texts we have long dismissed as metaphor. The stories of fire, wind, and darkness that appear across cultures. Stories that, when read without modern assumptions, begin to sound less like imagination and more like memory under pressure. The next layer of this story does not lie in the sky or in stone, but in language shaped by fear. Language that may carry the compressed testimony of a world that did not survive to tell it any other way. There is a moment in every excavation when language begins to fail. The symbols are familiar. The grammar is understood. Yet the meaning feels misaligned with expectation. What was once comfortably labelled myth begins to resist that category. The words refuse to stay symbolic. For decades, scholars translated Sumerian texts that spoke of fire from the sky, burning winds, and stones that fell from heaven, then quietly moved on. These passages were filed alongside epics and hymns, explained as metaphor, moral instruction, or divine drama. After all, early cultures personified nature. They explained disaster through gods because they lacked science. This assumption became a filter. Anything that sounded too catastrophic was smoothed into allegory. But what happens when the descriptions stop behaving like allegory? In the omen series known as Enuma Anu Enlil, the language is not poetic, it is conditional. When this happens, then that follows. The structure is diagnostic, not narrative. These are not stories meant to inspire. They are records meant to inform. Each celestial event is paired with a terrestrial consequence: famine, darkness, collapse, silence. One tablet recovered from Sippar describes a time when the wind came without clouds and the sun dimmed though no storm was present. Another warns of a season when stones of fire crossed the sky and the fields failed for years after. A third records the day the horizon burned, a phrase that appears nowhere else in Sumerian literature except in reference to celestial danger. These phrases are not explained. They are referenced as known phenomena. Myth typically expands. It embellishes. It repeats with variation. Eyewitness testimony compresses. It focuses on what mattered: heat, light, sound, duration, consequence. When Sumerian scribes wrote of the burning wind, they did not describe fear or punishment. They described effect. Crops failed, cities emptied, travel ceased. The emotional content is absent. The practical outcome is not. Across the ancient world, similar descriptions appear. The Egyptian texts speak of a time when the sky rained fire and the sun hid its face. The Hittite song of Ulikumi tells of stones falling from above and the earth trembling for days. In Mesoamerican codices, the world ends not in water alone, but in fire from the sky before the flood arrives. These cultures were separated by oceans and millennia, yet their disaster sequences align with unsettling precision. First light without thunder, then heat, then darkness that lingers, then famine, then water. This sequence matches no ordinary storm. It matches no volcanic eruption pattern known to ancient observers, but it aligns disturbingly well with what modern science recognizes as the aftermath of large atmospheric impacts. Airbursts, thermal radiation, shock waves, dust loading of the atmosphere. When a large cosmic object enters Earth's atmosphere, it does not need to strike the ground to devastate a region. It can explode mid-air, releasing energy equivalent to multiple nuclear weapons. The immediate effects include a blinding flash, intense heat, and a supersonic pressure wave. In the weeks and months that follow, fine debris can spread globally, dimming sunlight and disrupting climate. To a pre-industrial observer, this would appear as fire from the sky followed by a season of darkness. The Sumerians described exactly this. One tablet mentions the day when the river steamed and the field turned to glass. For years this was dismissed as metaphor, but vitrified soil, sand fused into glass, is a known byproduct of extreme heat events. It cannot be produced by ordinary fire. It requires temperatures reached during lightning strikes or cosmic impacts. Another text warns that after the sky event, no grain would grow for 7 years. Not forever, not a curse, a measured duration, 7 agricultural cycles. The specificity suggests observation, not invention. Myths exaggerate, records constrain. When scholars began comparing the dates associated with these omen texts to climate proxy data, unexpected correlations emerged. Ice cores from Greenland record periods of abrupt cooling. Sediment layers show spikes in atmospheric dust. Tree ring records reveal sudden growth suppression. Many of these anomalies align with the approximate periods referenced in Sumerian disaster texts. The overlap is not perfect. Ancient calendars shift, dates erode, but the pattern is persistent: catastrophe, darkness, recovery. Then generations later, another disruption. This rhythm appears again and again. What is most striking is what the Sumerians do not say. They do not moralize these events. They do not frame them as punishment for sin. The sky is dangerous but not judgmental. It is mechanical, predictable, indifferent. This worldview is incompatible with pure mythology. Myths explain meaning. These texts explain risk. The language reinforces this interpretation. Sumerian possessed different grammatical forms for recounting past events and for forecasting future ones. In many omen tablets, the future tense dominates. When the star crosses, when the fire appears, when the count completes. These are not stories of what happened once. They are warnings of what happens when conditions repeat. The scribes were not preserving legends. They were preserving scenarios. This changes how we read even the most famous Sumerian narratives. The Eridu Genesis, often treated as a flood myth, begins not with water but with disturbance in the heavens. The flood is a consequence, not the trigger. Fire and wind precede water. Darkness precedes rebirth. This is not a simple deluge story. It is a chain reaction. If these texts encode memories of cosmic disaster, then the Sumerians were not unique in remembering. They were unique in systematizing. Others told stories. Sumer counted. That counting implies repetition. A single catastrophe might traumatize. Repeated catastrophes teach pattern recognition. They teach timing. They teach preparation. The Sumerians appear to have understood that the sky did not behave randomly, that certain configurations brought danger, that certain seasons carried greater risk, that history, at least where the heavens were concerned, folded back on itself. And if that understanding came from experience rather than speculation, then somewhere in humanity's deeper past lies an event so profound that it reshaped not just landscapes, but the way civilization itself would be built. The next step is to look for that event not in stories, but in the earth itself, in layers that remember heat and pressure long after words fade. Because if the sky once reset the world, the planet would still bear the scar. Long after stories fade and cities dissolve back into dust, the earth remembers differently. It keeps its record not in words, but in layers. Thin seams of darkness pressed between sediments, particles too small to see without magnification. Structures formed only under pressures and temperatures no ordinary fire can reach. These are the marks of events that did not ask to be remembered, yet could not be erased. For much of the 20th century, geology told a calmer story of the past. Ice ages advanced and retreated gradually. Climate shifted over millennia. Change was slow, almost comforting in its predictability. Then, toward the end of the century, researchers began encountering something that refused to fit that rhythm. A boundary, thin, black, and global. At sites scattered across North America, Europe, and the Middle East, geologists noticed an unusual layer dating to approximately 12,800 years ago. It was rich in carbon, filled with microscopic spherules of melted material, and laced with nanodiamonds, tiny crystalline structures that form only under extreme pressure. These were not the signatures of ordinary wildfire or volcanic ash. They pointed to something far more violent. The Younger Dryas impact hypothesis was born from this anomaly. According to the hypothesis, Earth experienced a sudden cosmic encounter at the end of the last ice age. Not a single clean crater, but a swarm of fragments entering the atmosphere, exploding in a series of airbursts across the northern hemisphere. The immediate effects would have been devastating. Thermal radiation capable of igniting continent-scale fires. Shockwaves flattening forests and settlements. Within months, fine debris lofted into the atmosphere would have dimmed sunlight, plunging the planet back into near-glacial conditions for over 1,000 years. This abrupt return to cold is recorded clearly in ice cores. Oxygen isotope ratios shift sharply. Temperatures drop within decades, not centuries. Megafauna that had survived previous climate fluctuations vanish rapidly. Mammoths, giant ground sloths, saber-toothed cats disappear from the record almost simultaneously. Human cultures that had begun experimenting with sedentary life collapse or scatter. The world resets. What makes this event especially unsettling is not just its scale, but its speed. Nothing in Earth's recent history compares to the suddenness of the Younger Dryas onset. It does not behave like a gradual climate oscillation. It behaves like shock. One site in particular bridges this geological evidence with human experience. Abu Huraira, a settlement in what is now northern Syria, preserves a distinct burn layer dated precisely to the beginning of the Younger Dryas. Within that layer, researchers found glass-like carbon formations and melted building materials. The temperatures required to create these exceed anything produced by hearths, wildfires, or even volcanic fallout. The pattern of destruction suggests a powerful airburst overhead, not a slow-burning disaster. For the people who lived there, the sky would have become an instrument of annihilation in seconds. When this geological timeline is placed beside the language of ancient Near Eastern texts, an unsettling correspondence appears. Sumerian writings speak of a time they called before the waters, a world that ended not gently but violently, followed by darkness and then flood. The order matters. Fire first, then water. This is not how river floods behave, but it is how climate behaves after an atmospheric catastrophe. An impact winter would suppress evaporation and alter weather patterns. Ice sheets would grow. Meltwater would eventually surge, overwhelming low-lying regions. To survivors thousands of years later, these events might collapse into a single remembered cataclysm. But traces of sequence remain. The Earth preserves that sequence in sediment. Layers corresponding to the Younger Dryas boundary show widespread charcoal, evidence of massive fires. Above them, sediments indicate colder, wetter conditions. Rivers change course. Sea levels fluctuate. Human habitation patterns break, then slowly re-emerge. The land remembers what stories compress. If the Sumerians inherited memories of a world-ending event, this would explain their fixation on the sky as the origin point of disaster. The flood was not the beginning of destruction, it was the aftermath. The sky was the trigger. What is often overlooked is that the Younger Dryas was not merely a climate event, it was a cultural rupture. The archaeological record shows a long gap between pre-Younger Dryas settlements and the emergence of later complex societies. Knowledge was lost. Population densities fell. For generations, survival would have replaced experimentation. Memory would have narrowed to essentials. In such a world, the lesson that mattered most would be simple and terrifying. The sky can do this again. If that lesson survived, it would survive not as detailed explanation, but as priority. Watch the sky. Track its cycles. Never assume safety is permanent. Build systems that outlast individuals. Encode warnings in ritual and story so they cannot be forgotten even when their origin is. The Sumerians emerged thousands of years after the Younger Dryas, yet they behave like heirs to a trauma they did not personally witness. Their texts do not describe the event with detail. They reference it obliquely as something known, something foundational. Before the waters is not explained because it does not need to be. It is a shared reference point in deep time. This raises an uncomfortable possibility. What if the Sumerians were not speculating about cosmic danger at all? What if they were responding rationally to a geological memory encoded across generations? What if their civilization was shaped by the understanding that impacts are not singular freak accidents, but part of a larger pattern? Geology offers a disturbing hint in that direction. The Younger Dryas is not the only boundary layer that shows signs of sudden catastrophe. Similar, though less dramatic, markers appear at later points in the Holocene. Dust spikes, cooling events, abrupt societal collapses, none as severe as the Younger Dryas, but enough to suggest recurrence. The Earth does not erase such events, it stacks them. If the planet carries scars from multiple sky-driven disruptions, then ancient observers might have noticed that these catastrophes were not evenly spaced. They clustered. They followed rhythms tied not to Earth, but to Earth's path through space. And if those rhythms were detectable, then the most dangerous knowledge a civilization could possess would be the knowledge that the sky follows cycles too. The Younger Dryas shows us that a single encounter can reshape climate, ecology, and human history. It provides a physical anchor for ancient fear, but it also raises a question that refuses to stay buried. If it happened once, could it happen again? And if it could, would the Earth give warning before the next scar is written? The Sumerians seem to think so. To understand why, we must look not at catastrophe itself, but at the tools they built to ensure they would never be caught unaware again. When archaeologists first uncovered the great ziggurats of Mesopotamia, they described them as temples built to bridge earth and heaven, artificial mountains rising from flat plains, places where gods might descend and humans could reach upward in devotion. It was a satisfying explanation, elegant, symbolic, and incomplete. Because when these structures are examined not as monuments, but as instruments, their purpose begins to shift. At the ziggurat does not simply face a cardinal direction. Its corners and stairways align towards specific points along the horizon, points that correspond not to sunrise or sunset on ceremonial days, but to the rising of particular stars during particular seasons. The same pattern appears at Eridu, Nippur, and Uruk, different cities, different centuries, the same sky targets. This repetition is difficult to dismiss as coincidence. In a land where stone was scarce and mud brick precious, orientation was a choice that mattered. Builders did not align massive structures casually. Yet again and again, Sumerian sacred architecture privileges celestial sightlines over practical concerns. The temples are not optimized for defense. They are not positioned for trade routes. They are positioned for visibility. From the summit of a ziggurat, the horizon opens in all directions. The elevation removes obstacles. The angles matter. Narrow notches in walls frame specific regions of sky. Stairways double as sighting lines. Platforms create stable reference points that allow observers to notice subtle changes year after year. This is not symbolic design. It is functional geometry. At Eridu, the earliest known Sumerian city, archaeologists discovered something even more telling. 7 major temple layers were built on the same site across nearly 2 millennia. Each rebuild preserved the same basic orientation, but with slight adjustments. At first, these shifts were attributed to imprecision or ritual preference, but when astronomers later analyzed the alignments, another explanation emerged. The adjustments track precession. Earth's axis wobbles slowly over time, causing the apparent positions of stars to drift across the horizon. This movement is subtle, amounting to roughly 1 degree every 72 years. It is invisible within a single lifetime. Only by comparing observations across generations can it be detected. Yet the Sumerian temples correct for it. Someone noticed the drift. Someone recalibrated. This means the temples were not static monuments. They were maintained tools, like instruments that require periodic tuning to remain accurate. Each rebuild was not an act of tradition, but of maintenance. The priests were not honoring the past, they were updating the present. The implication is profound. The Sumerians were not simply watching the sky, they were watching it with continuity. At Nippur, the sacred courtyard forms a near-perfect observational enclosure. When standing at its center, specific horizon markers align with the rising points of Venus during critical phases of its cycle. Other sightlines correspond to the appearance of constellations associated in Sumerian texts with danger and disruption. These are not broad alignments meant to impress worshippers. They are precise, narrow, and practical. Why build such precision into religious space unless the observations mattered? In most cultures, sacred architecture encodes cosmology. It tells a story about the universe. In Sumer, the architecture encodes procedure. It tells you where to stand, where to look, when to watch. The temples functioned as shared memory devices. Even if the original meaning of a star faded, the building itself forced attention toward it at the correct time of year. Ritual ensured repetition. Repetition ensured observation. Observation ensured continuity. This design solves a problem that haunts all long-term risk awareness. How do you make future generations care about a danger they have never seen? The Sumerian solution was elegant. You disguise vigilance as worship. You embed instruction into tradition. You ensure that even when belief shifts, behavior remains. The architecture does not say why you are watching. It simply makes sure that you do. This helps explain why the most important temples were rebuilt even after cities declined. Political power shifted. Dynasties fell. Yet the sacred platforms endured. They were too important to abandon. Not because gods demanded it, but because someone always needed to watch. The sky does not announce itself with calendars. Dangerous objects can emerge from regions close to the sun, visible only at dawn or dusk, the times when light and darkness overlap. The Sumerians knew this. Their rituals emphasize liminal moments. First light, last light. Times when shadows stretch and vision is uncertain. The buildings reflect this knowledge. Many temple entrances face not east or west, but slightly offset, targeting heliacal risings. Moments when a star becomes visible just before sunrise after a period of invisibility. These events are not aesthetically impressive. They are scientifically useful. They mark timing with precision. This suggests that Sumerian observation was not passive. It was targeted. They were not cataloguing the sky in general. They were watching specific regions, specific seasons, specific alignments. Their architecture filters the heavens, narrowing infinite space into manageable zones of concern. If the sky held a recurring danger, this is exactly how one would track it. You define where it appears. You define when it appears. You build permanent reference points so that human memory does not have to carry the burden alone. Stone does not forget. When later cultures inherited these temples, they inherited the behavior without always understanding its origin. Ritual persisted, meaning softened. Observation continued. This may explain why certain sky-watching traditions survived long after their original context faded. The infrastructure enforced them. Seen this way, Sumerian religion begins to look less like devotion and more like a long-term monitoring system, a civilization-scale early warning network operating across centuries. If that is true, then the next question becomes unavoidable. What exactly were they watching for with such care? Not in myth, but in measurable terms. What phenomenon required this level of architectural commitment? The answer lies not in individual stars, but in something more elusive, a moving field of debris, a river of fire that Earth encounters again and again, often harmlessly, sometimes not. To understand why the Sumerians oriented their world the way they did, we must follow their gaze beyond temples and texts into the mechanics of the sky itself. To ancient observers, the sky appeared fixed and eternal. Stars rose and set with comforting regularity. Constellations returned on schedule. Yet scattered across this orderly backdrop were moments of chaos, sudden streaks of light, brief flares that cut across familiar patterns, falling stars that arrived without warning and vanished just as quickly. Most cultures treated these events as omens or curiosities. The Sumerians treated them as signals. Modern astronomy now recognizes that these flashes are not random. They are the visible traces of Earth moving through rivers of debris left behind by comets and fragmented celestial bodies. These debris streams wrap around the Sun, forming vast, invisible structures that intersect Earth's orbit at predictable times. Each year, as our planet passes through them, the atmosphere lights up. One of the most significant of these structures is the Torid meteor stream. Unlike short-lived meteor showers that peak sharply and fade, the Taurids are broad, slow, and persistent. Earth encounters them twice each year, once during the day in late June and early July, and again at night in late October and early November. Most of the time, the encounter is gentle. Small particles burn up high in the atmosphere, producing long, graceful fireballs. But the Torid stream is not uniform. Within it lie dense filaments and clusters of much larger fragments. Some are house-sized, others are hundreds of meters across. These objects are the remnants of a giant comet that fragmented tens of thousands of years ago, leaving behind a debris field so large that Earth has been moving through it ever since. When Earth passes through the diffuse edges of this stream, the result is spectacle. When it passes through the denser regions, the result can be catastrophe. This idea was formalized in the late 20th century by astronomers Victor Clube and Bill Napier, who proposed the theory of coherent catastrophism. According to their work, cosmic impacts are not evenly distributed across time. They cluster. Earth experiences long periods of relative calm, punctuated by intervals of elevated risk, driven by orbital mechanics and the structure of debris streams like the Taurids. The Torid complex in particular contains objects large enough to survive atmospheric entry or explode as devastating airbursts. Modern examples provide sobering confirmation. In 1908, a large object exploded over Tunguska in Siberia, flattening more than 2,000 square kilometers of forest. In 2013, a smaller but still powerful meteor detonated over Chelyabinsk, shattering windows across 6 cities and injuring more than 1,000 people. Both events occurred during Earth's passage through the Tarid stream. To modern observers, these incidents are treated as rare anomalies. To the Sumerians, they may have been part of a known pattern. The constellation Taurus, from which the Taurids appear to radiate, occupies a prominent place in Sumerian astronomy. The bull of heaven is not merely symbolic. It marks a region of the sky associated with danger, upheaval, and divine intervention. In multiple texts, the bull is linked not to fertility alone, but to destruction and judgment. This duality is telling. The Torid radiant lies near the Pleiades, a star cluster the Sumerians tracked with particular care. They noted its heliacal rising and setting, using it as a seasonal marker. But unlike benign agricultural markers, references to this region of the sky are often accompanied by warnings. When the bull stands high, when the cluster returns, when the count completes. These phrases recur across centuries. The slow speed of Torid meteors would have made them especially striking to ancient observers. Unlike fast showers that produce brief flashes, Taurids generate long-lasting fireballs that move deliberately across the sky, sometimes fragmenting visibly. To someone watching from a ziggurat platform, night after night, these events would stand out. They would be memorable. They would invite tracking. The Sumerians did not need telescopes to recognize that some seasons brought more fire from the sky than others. They needed only patience and continuity. Over generations, patterns would emerge. Certain months carried more risk. Certain configurations coincided with disruption. And occasionally, something far larger would appear, a brilliant object bright enough to cast shadows. A detonation that arrived seconds after the flash. A shockwave that could flatten walls and ignite fields. Such events would not be forgotten. The Torid stream presents another challenge that makes it particularly dangerous. Many of its objects approach Earth from directions close to the Sun. During the daytime stream, they arrive out of the glare of daylight. During the nighttime stream, they emerge from twilight. These are the hardest directions to monitor, even with modern instruments. The Sumerians understood this vulnerability intuitively. Their texts emphasize watching at dawn and dusk. Their rituals cluster around liminal light. Their temples frame the eastern and western horizons during precisely these times. This is not coincidence, it is strategy. If a civilization believed the sky could strike again, it would focus its attention where warning time is shortest, where danger emerges without ceremony, where light and darkness blur. Modern orbital simulations reveal something else that ancient observers could not calculate but might have inferred. The Torid stream's density fluctuates. Gravitational interactions with Jupiter and Saturn shepherd debris into clumps, creating periods when Earth's passage through the stream becomes far more hazardous. These intensification periods occur on timescales of centuries and millennia. To detect such cycles requires observation across vast stretches of time, longer than any individual life, longer even than most civilizations endure. Yet the Sumerians tracked long counts. They measured cycles that exceeded political timelines. They embedded numbers into their astronomy that make little sense for agriculture or ritual alone. If they were tracking the Taurids, these numbers begin to make sense. The stream of fire was not a constant threat. It was a sleeping one, mostly quiet, occasionally violent, and devastating when conditions aligned. Seen through this lens, the Sumerian fixation on the bull of heaven shifts from myth to map, from story to warning sign. The bull is not an animal, it is a region of space, a place Earth must pass through again and again. Most of the time, nothing happens, but sometimes something does. And if ancient humanity lived through one of those times, the memory would not fade easily. It would become encoded into stories, rituals, architecture, and mathematics. It would shape a civilization that did not trust the sky to remain harmless. The Torid stream offers a mechanism for recurrence, a way for catastrophe to return without randomness, a cosmic metronome ticking across deep time. If the Sumerians recognize this, even imperfectly, then their entire civilization begins to look like a response to orbital mechanics rather than superstition. They were not predicting the end of the world. They were monitoring a schedule. The next step is to understand how they measured that schedule, how they transformed fleeting streaks of light into long-term counts that spanned centuries. Because within their tablets lies a number that appears again and again, a number too large to belong to daily life, yet too precise to be coincidence. A number that may represent the rhythm of the sky's deadliest cycle. Among the thousands of tablets recovered from Mesopotamia, some resist easy categorization. They are not stories. They are not inventories. They are not prayers. They are numbers, long sequences of them, carefully arranged, repeated across copies made centuries apart, preserved with a consistency that suggests they mattered in ways modern readers have struggled to understand. One number appears more than any other. 3,600. In Sumerian notation, this value is not arbitrary. It is written as 60 times 60, a perfect square within their base 60 system. To later interpreters, it became tempting to see this number as symbolic, exaggerated, or mythological. But the Sumerians did not treat it that way. They treated it as a count, something to be tracked, completed, and reset. The tablets do not explain what happens when the count ends. They assume the reader already knows. This assumption is unsettling. In administrative texts, numbers are contextualized. They count sheep, jars of oil, days of labor. In astronomical texts, numbers often mark cycles, intervals, and returns. The 3,600-year count appears only in the latter. It is associated with celestial language, with crossings, with danger, with what the texts call the time of completion. Why would a civilization measure time on a scale far exceeding any political dynasty, any temple lifespan, any human memory? One explanation is ceremonial exaggeration, another is inheritance. If the Sumerians believed the sky followed long cycles of threat, then their mathematics needed to extend beyond lived experience. They would need to count what they could not personally witness, to trust numbers more than memory, to preserve warning beyond the horizon of myth. The base 60 system makes this possible. It allows complex subdivision without fractions. It enables nested cycles, smaller rhythms embedded within larger ones, days within months, months within years, years within greater counts. When applied to celestial observation, this system excels at tracking periodicity. In the Emule A-pin and related texts, we see exactly this structure. Short-term cycles nested within longer ones. Venus's 584-day cycle tracked alongside lunar months. Jupiter's 12-year return placed within broader temporal frameworks. And above them all, references to long counts that reset when a greater cycle completes. The language shifts subtly at these points. The tone becomes cautionary, conditional. When the count completes, the texts warn, watch carefully. Modern astronomy offers a provocative parallel. Studies of the Torid meteor stream reveal that its density is not constant across millennia. Gravitational interactions, particularly with Jupiter, herd debris into filaments that drift and disperse over time. Computer models show periods when Earth's orbit intersects these dense filaments, dramatically increasing the probability of large impacts or airbursts. These intensification windows recur on timescales measured not in decades, but in thousands of years. The exact periodicity varies depending on modeling assumptions, but many simulations cluster around intervals of roughly 3,000 to 4,000 years. Close enough to make coincidence uncomfortable. The Sumerians would not have known gravitational mechanics. They would not have modeled orbital resonances. But they did not need to. They needed only continuity. Observation passed from one generation to the next. Memory preserved not in individuals, but in institutions. If an ancient society experienced a catastrophic encounter during a dense Torid passage, the aftermath would shape behavior for centuries. The survivors would watch. Their descendants would inherit the watch. Over time, the recurrence of lesser events, fireballs, airbursts, seasons of unusual activity would reinforce the pattern. Eventually, someone would count. The Sumerian texts suggest that someone did. One tablet from Uruk describes what it calls the return of the crossing star when the great count is fulfilled. The phrasing is precise. Not if it returns. When? Another text links the completion of the count to a season of danger, marked by specific stellar positions. These are not open-ended prophecies. They are conditional forecasts. They imply that time itself is a mechanism. This perspective aligns with the broader Sumerian worldview. Time was not linear progression. It was accumulation, cycles within cycles, repetition rather than novelty. Kingship itself was said to descend from heaven, be lost, and return. Cities rose, fell, and were rebuilt. Even the gods followed rhythms. In such a worldview, catastrophe is not an ending. It is a phase. The 3,600-year count appears again in later Mesopotamian traditions under different names. In Akkadian texts, it is associated with great renewals and great disruptions. In later astronomical writings, similar long counts persist, stripped of their original context but retaining their numerical form. Numbers are stubborn that way. They outlive explanation. What makes the Sumerian count especially unsettling is that it does not belong to agriculture. Crops follow yearly cycles. Floods follow seasonal ones. Even long droughts resolve within generations. A 3,600-year cycle belongs to the sky alone. If the Sumerians were wrong, this number would be meaningless, a relic of numerological imagination. But if they were right, even approximately, then the count represents something far more dangerous, a rhythm humanity does not experience often enough to remember instinctively. We experience only one slice of it. This may explain why the Sumerians placed so much emphasis on preservation, why they encoded numbers into multiple textual traditions, why they treated astronomical knowledge as sacred duty rather than intellectual curiosity. Forgetting the count would not erase the cycle. It would only ensure surprise. The idea that ancient observers identified long-term impact cycles is uncomfortable because it challenges a deeply held modern assumption. That civilization progresses steadily towards safety. That knowledge accumulates. That disaster is something we outgrow. The Sumerians did not appear to share that confidence. They behaved like people who believed knowledge could be lost faster than danger disappears, like people who understood that technological sophistication does not guarantee awareness, that a society can forget how to watch even while it builds higher walls. If the sky's deadliest cycle unfolds over millennia, then forgetting is not a failure of intelligence, it is a consequence of time. The Sumerian solution was to externalize memory, to place it in clay, in stone, in ritual, in number, to ensure that even when language shifted and empires collapsed, the count itself would persist, waiting to be recognized again. Whether or not their numbers align perfectly with modern models is almost beside the point. What matters is that they believed recurrence was real enough to demand counting. And if they believed that, the next question becomes more unsettling still. Did they believe the count pointed forward as well as backward? Were these numbers meant not just to explain the past, but to warn the future? To answer that, we must look at a strange feature of the omen texts that has long been overlooked. Not what they describe, but how they are written. The tense they use, the audience they imply, the unmistakable sense that some of these words were never meant for the people who wrote them. Some tablets speak as if they know they will be read by someone else. Not a king, not a priest, not even a contemporary audience. They are written with a distance that feels deliberate, as though the scribes understood that the meaning of their words might outlive the world they knew. This becomes clear not in what the texts describe, but in how they describe it. Sumerian, like many ancient languages, possesses multiple ways to situate events in time. There are forms used to recount completed actions, others to describe ongoing states, and still others reserved for expectation, for things that have not yet happened but are anticipated under certain conditions. When linguists began examining omen texts with this grammatical lens, a pattern emerged that was difficult to ignore. Many of the most severe celestial warnings are written almost entirely in the future tense. These are not stories of what once occurred. They are conditional instructions. When the star crosses, when the fire appears, when the count completes. If these signs are seen, then this will follow. The grammar is unambiguous. This is forecasting, not remembrance. One tablet from Sippar illustrates this clearly. It describes a celestial configuration involving a bright object crossing a known star path during a specific season. The consequence is not immediate. The text states that famine will follow in the 7th cycle, not the 7th day, not the 7th month, the 7th agricultural year. The delay is built into the warning. This level of temporal specificity is striking. It implies that the scribes had observed not only the initial event, but its downstream effects across multiple seasons. They knew that destruction unfolded in stages. First the sky event, then atmospheric disruption, then long-term ecological collapse. This is not prophecy in the mystical sense. It is prediction based on pattern. Even more unsettling are tablets that explicitly state their purpose. One fragment, badly damaged but partially legible, includes a line that translates roughly as, "This is written for those who come after, so that the count will not be lost." The phrase is rare. It does not appear in hymns or royal inscriptions. It appears only in astronomical contexts. The audience is not present, it is imagined. This suggests that the scribes were acutely aware of cultural fragility. They understood that knowledge could vanish, that cities could fall, that language itself might shift beyond recognition. Yet they wrote anyway, trusting that someone, someday, might rediscover the logic embedded in their words. The Omen series known as Enuma Anu Enlil reinforces this impression. Its tablets do not merely list events, they organize them into scenarios, conjunctions, sequences. Many of these scenarios have no known historical correlate in the Sumerian period itself. They describe combinations of celestial signs that did not occur within the lifespan of the scribes. Why record events you have never seen? The simplest answer is speculation, but speculation rarely invests in detail without payoff. These texts invest heavily. They specify months, star positions, directions, outcomes measured in years. This is not imaginative excess. It is contingency planning. Some tablets go further still. They include calculations that project far beyond the date of writing. Long sequences of numbers that, when converted from base 60 notation, extend forward by centuries or millennia. These calculations have puzzled scholars for decades because they do not align neatly with known planetary cycles. They appear to combine multiple rhythms into a single projection. Only recently have researchers begun to test these calculations against modern astronomical models. When they do, a provocative alignment appears. Some of the projected windows correspond to periods of increased meteor activity inferred from historical records and orbital simulations. The matches are not exact, but they cluster more often than chance would suggest. This raises a difficult question. How could ancient observers project risk so far into the future without understanding orbital mechanics? The answer may lie not in precise prediction, but in conservative extrapolation. If you know that danger clusters, if you know that clusters recur, you can estimate windows of heightened risk even without knowing the underlying physics. The Sumerians may not have known why the cycle returned. They may only have known that it did. The future tense of the texts reflects this mindset. They do not claim certainty. They offer conditions. If these signs align, then watch closely. If fire appears where it should not, prepare. The tone is cautious, not apocalyptic. It assumes agency on the part of the reader. This is another clue that these were not religious prophecies. True prophecy demands belief. These texts demand attention. The scribes seem to have understood that whoever read their words would not share their context, that the rituals might have changed, that the gods might be renamed, that the original fear might have softened into story. So they embedded redundancy, numbers repeated across tablets, cycles nested within cycles, the same warnings phrased multiple ways. They were writing against forgetting. In one particularly haunting fragment, the text describes a moment when the fire returns but no one watches. The line is ambiguous, but the implication is stark. Danger unobserved is danger doubled. The sky does not warn loudly. It rewards attention and punishes neglect. This anxiety makes sense if the scribes believed that their civilization might not survive to witness the next cycle, that the responsibility would fall to strangers, to people who did not share their language, their land, or their gods. We are uncomfortably close to fitting that description. If the Sumerians expected future readers, then their warnings were not meant to be dramatic. They were meant to be deciphered, to be recognized by a culture capable of correlating sky patterns with physical evidence. A culture that could look back and see the scars in the earth. In that sense, the tablets are not messages to the past. They are messages to the future. But messages alone are fragile. Words can be mistranslated. Context can vanish. The Sumerians understood this too. which is why they did not rely on texts alone. They built redundancy into their entire society. The next layer of their warning system was not linguistic at all. It was social, ritualized, lived out across generations so that even if the meaning faded, the behavior endured. To understand how they achieved that, we must look at Sumerian religion not as belief, but as infrastructure, as a system designed not to explain the sky, but to keep watching it long after explanation was forgotten. To modernize, Sumerian religion appears crowded with gods, rituals, and symbols, layered atop one another until meaning blurs into mythology. Storm gods hurl winds. Sky deities bring judgment. Festivals repeat with elaborate precision whose original logic seems long forgotten. For centuries, scholars assumed this complexity reflected early humanity's attempt to explain an unpredictable world through divine personalities. But what if explanation was never the point? When the religious calendar of Sumer is laid alongside its astronomical record, an unexpected alignment appears. The most important rituals do not cluster around agricultural milestones alone. They cluster around moments of celestial transition, equinoxes, solstices, heliacal risings, periods when the sky changes its behavior, not symbolically, but observationally. The Akitu festival, the most sacred ceremony in the Sumerian year, is often described as a celebration of renewal and kingship. Yet its structure is strange if viewed purely as religious theatre. It lasts precisely 11 days. During this time, priests are required to perform repeated observations of the heavens at fixed intervals: dawn, midday, sunset, midnight. Each observation is recorded. Any anomaly is noted. Any unexpected light is treated seriously. This is not worship, it is surveillance. The timing of Akitu is equally revealing. It begins at the spring equinox, when Earth's orbit shifts relative to the Sun and the geometry of sky visibility changes. This is also when Earth begins its approach toward the daytime Torid stream. Though the daytime stream produces fewer visible meteors, it represents the beginning of a seasonal risk corridor. The ritual marks that threshold. Other festivals map onto other risk windows. Late autumn ceremonies at Uruk coincide precisely with the peak of the nighttime Torid stream, when Earth passes through the densest region of debris. Lunar rituals align with eclipse seasons, when the geometry of Earth, Moon, and Sun produces predictable shadow crossings. Even celebrations associated with fire correspond to known meteor shower peaks. These correlations are not perfect, but they are persistent. Too persistent to ignore. What scholars have long treated as agricultural timing appears instead to be a skywatch calendar disguised as religion. The rituals ensured that large numbers of people, especially trained observers, would be watching the sky at precisely the moments when danger was statistically elevated. This disguise was necessary. A warning system that relies on belief alone fails when belief shifts. But a warning system embedded in tradition survives skepticism. Even when later generations no longer understand why they perform a ritual, they still perform it. Behavior outlives explanation. The Sumerian priesthood reflects this logic. Priests were not selected primarily for spiritual devotion. They were trained as scribes, mathematicians, astronomers. Their education included geometry, calculation, star identification, and long cycle counting. Ritual recitation and mythological knowledge were layered atop a technical foundation. This was not accidental. The priesthood functioned as a scientific institution whose legitimacy was protected by religious authority. Failure to perform sky-watching duties carried severe penalties. Tablets describe punishments for priests who neglected their observational responsibilities during designated danger periods. Exile, confiscation, in extreme cases, execution. Such punishments make little sense for symbolic neglect. They make perfect sense for failure in an early warning system. The gods themselves encode this system. Enlil, often translated as a storm god, governs wind without rain. His breath flattens cities. He darkens the sky. These descriptions align not with weather, but with shockwaves and atmospheric blasts. Nergal, lord of the underworld, is associated with fire from below, scorched earth, and sudden death, imagery consistent with thermal destruction rather than moral judgment. Inanna, tied to Venus, embodies both beauty and violence, reflecting the planet's role as a timing marker that can signal either benign cycles or dangerous alignments depending on context. These gods are not moral teachers. They are mnemonic devices. Each deity compresses a set of observations into a story that can be remembered. Children may not understand orbital mechanics, but they can remember that when the bull rages, disaster follows. They can remember that certain stars bring hunger. The myth preserves the rule even when the reason fades. The Enuma Elish, often read as a creation epic, contains another layer of this encoding. Marduk defeats Tiamat by shattering her body, scattering fragments across the heavens to form a band that encircles the sky. This is usually interpreted as cosmic symbolism, but the imagery is uncomfortably precise. A large body breaks apart. Its fragments form a ring. That ring becomes a recurring presence. It reads less like theology and more like a description of a debris field. Religion, in this light, becomes a storage medium, a way to carry technical knowledge through periods of instability. When writing falters, when cities burn, when political power collapses, the stories survive because they are told, sung, and enacted. The Sumerians did not trust memory alone. They trusted repetition. This explains why their religious system appears redundant. The same warnings appear in multiple forms: text, ritual, architecture, story, number. If one fails, another persists. The system is robust because it expects failure. Seen this way, Sumerian religion is not an attempt to control the gods. It is an attempt to control forgetting. The civilization that emerges from this framework is not one seeking divine favor. It is one bracing against recurrence. Its rituals do not ask the sky for mercy. They demand attention from those who live beneath it. By the time later empires inherited these practices, much of the original context had softened. Ritual became tradition. Surveillance became ceremony. But the skeleton remained. The calendar still guided eyes upward at the right moments. The myths still whispered danger where scholars heard poetry. If the Sumerians were wrong, this system was an elaborate waste of effort. But if they were even partially right, then they achieved something extraordinary. They built a civilization-scale memory system capable of carrying warnings across thousands of years. Which brings us to the present. We have stripped ritual of meaning. We have replaced shared vigilance with specialized instruments. We assume that modern technology makes ancient fears obsolete, but the sky the Sumerians watched is the same sky above us now. The debris streams have not disappeared. The cycles have not stopped. What has changed is our relationship to memory. The Sumerians assumed that catastrophe would return and built their society accordingly. We assume that catastrophe is unlikely and build as if memory itself were unnecessary. If the ancient system was designed to speak to strangers, then perhaps the final stage of this story is not ancient at all. It is contemporary. It lies in the moment when modern science begins to rediscover patterns that ancient observers feared and must decide whether to treat them as abstract probabilities or as lived risk. The cycle, if it exists, does not announce itself dramatically. It emerges quietly, in numbers, in simulations, in data points buried in reports few people read, and like the Sumerian warnings, it waits for someone to notice. In the modern world, danger rarely announces itself with fire in the sky. It arrives instead as data, as probability curves, as quiet updates to reports that circulate briefly among specialists before disappearing into archives. The language has changed, but the pattern has not. What ancient scribes pressed into clay, modern scientists encode into simulations, and in those simulations, something familiar is beginning to emerge. In 2022, NASA's Planetary Defense Coordination Office released an updated assessment of near-Earth object risk. Buried within the technical language was a detail that received little public attention. Earth's orbit, the report noted, would pass through a region of increased debris density associated with the Torid complex during the coming decades. Not unprecedented, not catastrophic by default, but elevated compared to the recent past. The timing was uncomfortably precise. Independent teams modelling the Taurid stream have reached similar conclusions. Orbital simulations show that gravitational perturbations from Jupiter and Saturn periodically concentrate fragments into denser filaments. These filaments drift slowly, spreading and reconverging over centuries. When Earth's orbit intersects one of these concentrations, the statistical likelihood of large fireballs and airbursts increases dramatically. This does not mean impact is inevitable. Most years pass quietly, but risk is not binary. It is a gradient. Ancient observers may not have known the physics, but they understood the gradient. They watched for seasons when the sky behaved differently, when fire appeared more often, when the heavens seemed restless, and they recorded those seasons not as anomalies, but as signals. Modern data suggests we may be entering one of those seasons. Between 2030 and 2040, Earth's orbital geometry places it deeper within the Torid debris complex than it has been for generations. This window does not guarantee disaster, just as previous windows did not always culminate in catastrophe. But the probability curve bends upward. The same curve ancient observers may have learned to fear. Historical records hint that similar windows in the past were not always quiet. Medieval chronicles describe unusual atmospheric phenomena during the 14th and 15th centuries. Extended periods of dim sunlight, crop failures, reports of fire in the sky. While these accounts lack the precision of modern data, they align with periods when orbital reconstructions suggest elevated Taurid activity. The Sumerian counting tablets projected such windows forward, not to predict a single moment of doom, but to mark eras of heightened vigilance. Their language does not say the world will end. It says, watch carefully. This distinction matters. We are conditioned to interpret ancient warnings as apocalyptic prophecy, but the Sumerians were not concerned with endings. They were concerned with recurrence. Their fear was not that the sky would destroy everything, but that it would do enough damage to reset progress again and again. Seen through this lens, their system was remarkably rational. They did not abandon the sky in terror. They studied it. They built institutions to observe it. They encoded its rhythms into culture so that even when belief systems shifted, attention would remain. Modern civilization has taken a different approach. We have delegated vigilance to machines and agencies. We assume specialization replaces shared awareness, that someone, somewhere, is watching on our behalf. In many ways, this is true. Telescopes scan the skies. Radar tracks near-Earth objects. Databases grow daily. Yet the human relationship to the threat has thinned. Awareness has become abstract. The sky is no longer part of daily consciousness. This may be our greatest vulnerability. The Sumerians assumed that knowledge could be lost, that institutions could fail, that vigilance had to be distributed across society to survive collapse. We assume continuity. We assume that progress accumulates, that once a risk is identified, it remains identified forever. History suggests otherwise. Knowledge fragments, priorities shift, data without narrative becomes noise. The Sumerians understood this intuitively. That is why they wrapped warning in story, why they embedded counting in ritual, why they treated skywatching as sacred obligation rather than optional expertise. They expected forgetting. If the cycles they tracked are real, then we are not living at the end of the story, but in another turning of it. One where ancient fear and modern science briefly overlap, where data begins to echo memory, where numbers align with warnings pressed into clay thousands of years ago. This does not mean the Sumerians predicted our future. It means they recognized a pattern larger than themselves. A pattern that does not care who watches it, only whether anyone does. As you listen now, perhaps in darkness, perhaps drifting towards sleep, consider the symmetry of the moment. Ancient scribes sat by lamplight, pressing warnings into wet clay, knowing they would never see the time they were writing for. Modern scientists sit before glowing screens, refining simulations that describe risks they may never personally witness. Both are acts of faith. Faith that someone will care. Faith that attention matters. Faith that understanding the sky, even imperfectly, is better than ignoring it entirely. The Sumerians believed the sky followed a cycle, that danger returned, that memory was humanity's only defense against surprise. They built their civilization around that belief, not because it was comforting, but because it was necessary. We stand beneath the same sky now. The stars rise as they always have. The debris streams remain invisible. Most nights pass quietly. And yet, somewhere in the numbers, in the simulations, in the quiet updates few people read, the same ancient rhythm continues. Whether it will express itself dramatically in our time is unknown. The Sumerians never claimed certainty. They claimed recurrence. The question they left behind was never when the next catastrophe would come. It was simpler and far more demanding. Would anyone still be watching when it did? If this journey resonated with you, you can support the channel in a simple way by liking the video, sharing it with someone who might find these ideas meaningful, and subscribing if you'd like to continue exploring these forgotten questions together. Thank you for listening and for being part of this quiet watch.